All right, we're working on Algebra 2, 2.2, Chapter 2.2, Linear Inequalities. All right, we're talking about graphing inequalities first. So an equation is a statement of equality between two algebraic equations. So with an equation, we're going to see the sign equals. And that's extremely important. I've talked about it before. That tells me that whatever on this side is exactly the same as what's on the other side. So I can interchange them either way I want. So if I have x equals 5, and anywhere I see a 5, I can replace it with x, or anywhere I see an x, I can replace it with 5. So equations are super important to us. That's what we deal with mostly, but we also work with inequalities, something that's not equal to. So the way that we'll see inequalities is there's a few different ways. We can see less than, we can see less than or equal to, we can see greater than, and we can see greater than or equal to. And we can see something that just says not equal. All right, so less than or equal, greater than or equal, and then just not equal. All right. The way we've seen that before might be something like 2 is less than 5. 2 is less than or equal to 2. 3 is greater than 1. 3 is greater than or equal to 2. And then we can just say 3 does not equal 2. So that's the way we would say with numbers. For us, though, being in algebra, we're going to have some letters in there, variables in there throughout. All right, so you need to be familiar with less than or equal to, greater than or equal to, not equal to. All right? That's the different inequality symbols that we use. So when we solve an inequality, our answer is going to be left as an interval. So if I have something like, with an equation, if I have x plus 1 equals 2, I know that I need to isolate that variable, subtract 1 from both sides, and I get x is equal to -1. So I got exactly what x was equal to, a specific number. When I solve it with an inequality, what I'm going to be left with is something like x is less than 1. All right, so x could be anything that's less than 1. It could be 0.5, it could be 0, it could be -7. There's an infinite number of numbers that are smaller than 1 because it's everything from 0.99999. It doesn't include 1. I can get it infinitely close to 1, but it's not going to include 1. So it can be anything from -infinity all the way to 0.9999 and on. That's going to be called an interval. So our answers with the inequalities are going to be intervals. It's going to be from this point to this point. They'll be, in this case, I want to graph it, and I'm going to graph it on a number line. So let's just, we'll use, the book uses the example, x is greater than 3. So if I want to graph this inequality on a number line, first thing I'm going to do is find the number that it's talking about. X is by itself. I've got to make sure that my variable is isolated. And whatever's on the other side, I'm going to find that number on my number line, so I've got 3. 3 is right here. I'm going to put a circle right here. All right, what I need to know is that a circle is not equal a closed dot. All right, we're going to use one of our new symbols here. A circle, an open circle, is not equal to a closed dot. I use an open circle if it's less than or greater than. I use an open circle. If it's less than or equal to, greater than or equal to, I use the closed dot. All right, so when I'm looking at my inequality on a number line, if it's an open circle, I know that it's either going to be less than or greater than. The way I'm going to decide is which way is it shaded. this said x is greater than 3, so I need to shade everything that's greater than 3. So I found my 3, I put my open circle on it because it's greater than, and then I'm going to shade everything above that. So I basically know that this inequality covers everything from 3 but not including 3, all the way up to this line goes infinitely on to positive infinity. If it was less than, it would have gone to negative infinity. All right, so that's how we graph an inequality. We'll look at a couple more. Let's do one. X is less than or equal to negative 2. All right, so I'm going to make my number line. I don't necessarily have to start at 0. I can start anywhere I want. I'm just going to go and put my negative 2, and I'll just put a few around it, just to get a little bit of reference. So negative 4, negative 3, negative 2, negative 1, 0. Of course, we keep on going to 1. It goes all the way to positive infinity, back to negative infinity. So same thing, I'm going to find the x is isolated, x is by itself. I'm going to find the number on the other side, which is a negative 2. And this one is or equal to. And like we said, if it's or equal to, I'm using a closed dot. So on negative 2, I'm going to use a closed dot. All right, now I got to decide which way am I going to shade? Am I going to shade to the left or am I going to shade to the right? I need to shade all the values of x that are less than negative 2. If it's less than, it's going to be going towards this direction. Now, a little trick you can do is if you have the variable on the left side, you're always going to shade the way the symbol points. So this one points to the right, I shade it to the right. This one points to the left, I shade it to the left. Where I have to be careful with that rule. It works most of the time. But I need to understand that x being less than or equal to negative 2 is the same thing as negative 2 is greater than or equal to x. So if x is on the right side, it means exactly the same thing. Negative 2 is greater than all of these values, so they mean the same thing. But when my x is on the right side, I can't do that little trick of following the direction of the arrow on my inequality sign. All right, so this is my endpoint. My interval is from negative infinity to that endpoint. This is unbounded. All right, unbounded means that at least one direction it goes on infinitely. It doesn't stop. All right, there's also what we call compound linear inequalities. A compound linear inequality is going to be something that would look like, let's say, negative 1 is less than x, which is less than 3. All right, so if I want to graph that compound linear inequality, I start with my number line just the same. I need to make sure I have a negative 1 on it, and I need to have a 3 on it. So I go negative 1, 0, 1, 2, 3. Maybe just put a couple for good measure. The 2 points that I'm going to have are negative 1 and 3, and it's not or equal to, so I'm going to use my open circle. So at negative 1, it's an open circle. At 3, it's an open circle. It's possible that this could have been or equal to if one of these is a closed dot, but in this case, they're both open circles. And I know that x is in between negative 1 and 3. So it's in between negative 1 and 3. And if I get confused, if I don't know if maybe it should have been on the outsides, which is possible, I can pick a test point. If I look in between these and I pick, let's just say I pick 1, and I say let x equal 1. Negative 1 is less than 1, which is less than 3. That's true. Negative 1 is less than 1, and 1 is less than 3, so I filled the right spot based off that test point. All right, let's look at one. Let's see, let's look at one that may be a little bit more challenging. Let's go negative 5 less than or equal to x, which is less than positive 4. So I'm going to make my number line. I need to make sure I go from at least from negative 5 all the way to positive 4. So I'll start with negative 5 here, negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, just for good measure, do 1 on the other side. All right, so the small end, -5, less than or equal to. Or equal to is closed dot, so at -5 I'm using a closed dot. My other end, 4, just less than, it's an open circle. X is in between those two, I can pick a test point, let's pick 0. If I pick 0 that's in between these two dots, does it make it, it's a true statement. -5 is less than or equal to 0, that's true, it's less than 0, it's farther to the left. 0 is less than 4, is that true? 0 is to the left of 4, so it is less than, so that's true. So this would be where I shade, right down the middle, all the way to my other dot, all right? So these are bounded intervals. A minute ago, whenever I had something like x is greater than 4, that's unbound, because in one direction it goes on infinitely. On compound inequalities, you'll usually find them to be bound because they're sandwiched in between two endpoints. This one is mixed. It's mixed because it has one closed dot and it has one open circle. All right, so another way we can write these, we have several different notations. So we've talked about notation, the definition of that's it's the way that you write something. So types of intervals, unbounded, I could have in any inequality notation. And that might look like x is less than k. In interval notation, so inequality notation is going to have an inequality. It's going to have a less than, greater than, less than or equal to, greater than or equal to, or not equal to. It'll have an inequality symbol. Interval notation is basically going to give me everything that it could be. All right, so in this case, if x is less than k, that means it's anything from -infinity up to k. Now, because it's not or equal to k, just like I had open dots and closed dots, whenever I'm doing interval notation, I'm going to use parentheses or brackets. If it's not or equal to, then I'm going to use a parenthesis. All right? And then lastly, we have the number line representation. And this will just kind of put it all together. If this is k, k can be any number. I know it looks a little bit weird using just variables, but k can be any number on there. What we know is it's less than, so it's going to be an open circle. My variable that my x is on the left, pointing to the left, and then mark everything to the left of it. So this is telling me that x can be anything that's in the shaded all the way up to k, but not including it. This is telling me that it can be anything from -infinity up to k, not including it. The parenthesis says not including it, the bracket said would. And this is telling me x is less than k. So they mean, all three of these things mean basically the exact same thing, they just look different, different notations. All right, so that is an unbounded open. Open and unbounded. Open means that it's an open circle. Unbounded means that it goes to infinity one way or the other. All right, if I have something like x is less than or equal to k, that is now a closed but unbounded. It's closed because it has or equal to. My interval notation here would look very similar because it's less than. I know it's going to go to -infinity and it's going to go all the way to k, but because it's or equal to, if this has a flat line in it, I need a flat line on my bracket. All right, so that means it includes k. This one means it does not include k. Just like on my number line, I'm going to go all the way to k, but I'm going to use a closed dot, and I'm going to show you this way. All right, so the only difference is the or equal to between the two of them. We can have one we haven't looked at yet. Let's look at x is not equal to k. All right, this one I want to do the number line first so we can kind of see what's happening. If x is not equal to k, not equal to, so I don't have an equal sign, that means it's going to be an open circle. So if it cannot equal k, what can it be? It could be anything else. It could be anything smaller than, or it could be anything greater than. So I'm going to show you both directions whenever it says it's not equal to. All right? When I do interval notation, I've got to write it in a way that represents everything that x can be. So I know x can be anything from negative infinity all the way up to whatever k is, not including k. And now if I'm going to put union, this u means union, which basically means and. It can be anything from k to positive infinity. All right, so it can be anything from negative infinity all the way to k, not including k, that's what the parentheses mean. And it can be anything to positive infinity. So again, x doesn't equal k, which means it does equal, or it can equal anything from negative infinity up to k, anything from k to positive infinity, and the number line says k is the only thing it cannot be. All right, so those are unbounded ones. If we look at a bounded one, let's say a is less than x, which is less than b. So this is an open, bounded. It's open because neither one of them are equal to. All right, so x is somewhere between a and b, not equal to. So I know it's going to be anywhere from a to b, and it's not going to be equal to either one of them. All right, so this is the interval notation. It can be anything from a to b, but not equal to either one of them. Number line, that would look something like there's a, there's b, it does not include a, it does not include b, but it can be anything in between these two things. All right, we'll do one more. That's an open one because it's not equal to. Let's do one that's mixed. Mixed and bounded. All right, so that would be something like a is less than or equal to x. That would be closed because it's already equal to, which is less than b. So that one's open. Closed open means it's mixed, and it's bounded because it's in between these two things. So the difference here is that it can equal to a, but it cannot equal to b. A to b cannot equal using the bracket, can equal using the bracket, cannot equal using parentheses. The only difference on our number line, we're going to have a, and it's going to be a solid circle. And you have b with an open circle, and it can be anything in between. All right, so that's the three different notations that we're most likely to use. If it tells you to write it in inequality notation, it has to look like this. You can do this and you're still wrong, even though you may have done this notation correctly. So you've got to make sure that when it says to graph it on a number line, you're putting it on a number line. If it says to give the answer in interval notation, you do so. And if it says to give it in inequality notation, you do that as well. So you're going to have to make sure you read the directions on these and that you get those right. All right, so okay, so example 2.2a, identify each inequality as bounded or unbounded and write in interval notation. So the answer should say bounded or unbounded, and it should be in interval notation. So it gave us x is greater than -4. One of those I can already answer. X is not sandwiched between anything. This one is going to be unbounded. All right. Now, if x is greater than -4, what I know is that it goes from -4, not including, so I'm going to use parentheses, and it can go anywhere from -4 all the way, because it's unbounded, it can go all the way up to positive infinity. All right, so unbounded, -4 to infinity, parentheses on both ends. We always have parentheses on infinity because infinity is not a number, and it keeps going, so we know it doesn't include that. All right, so let's look at solving some linear inequalities. When we learned how to solve equations, we learned that if we had something like, let's look at example 2.2b, 3x plus 2 is greater than 5. All right, so this wants us to solve the inequality, and it wants us to express the solution as an inequality and in interval notation. All right, so we should get x on one side of the inequality by itself, and then we should have two answers. We should have it as an inequality, and we should have it as interval notation. So when we learned how to, if this was an equal sign, let's just pretend for a second that this was an equal sign. When we learned how to solve these, we learned about the addition property of equality and the addition property of inequality, addition property of equality and the multiplication property of equality. The addition property of equality is kind of the foundation of solving all algebra problems, because it tells us that I can add or subtract anything I want to this side as long as I do the same thing to this side. That rule, that addition property of equality, is the same for the addition property of inequality. I can add or subtract anything I want from either side, and it won't change the inequality. But the multiplication property of inequality is a little bit different than the multiplication of inequality, and I'll show you why. Put this back where it was. Let's just do one that's obvious. Let's say 2 is less than 4. All right, that's true. 2 is less than 4. The addition property of inequality says I can add anything I want to both sides and it stays true. So if I add 2 to both sides, I get 4 is less than 6. That's still true. So adding it doesn't change anything. I can subtract. I can subtract that 2 back away from it, and I get 2 is less than 4 again. So adding and subtracting to an inequality doesn't change anything. It's still a true statement. Just like with equations. But with multiplication and division, that's where it changes. If I multiply this side by a -2, and I multiply this side by a -2, I'm allowed to do that. I can multiply as long as I do it to both sides. -2 times +2 is -4. Less than 4 times -2 is -8. Here's where I run into a problem. -4 is not less than -8. I know that because if I put them on a number line, here's 0, here's -4. I have to keep going to the left to get -8. -8 is smaller than -4. So there's a rule that I have to memorize, that you have to memorize. When I multiply or divide by a negative, when you multiply or divide by a negative, you have to flip your inequality. Flip the inequality. All right, so what that would look like is when I multiplied both sides by -2, I needed to flip my inequality. -4 is greater than -8. If we'll do that every time we multiply or divide by a negative, we'll do fine on inequalities. Really, this lesson isn't anything new other than you had to learn the multiplicative rules for inequalities as opposed to equations, all right? The multiplicative property of inequality. So let's go to solve this one. I need to get x by itself. Just like if it was an equation, I would need to move the 2 over first by constant. I always want to work away from the variable, from the outside in. So I have 3x plus 2. Let's get rid of that plus 2 first. It was being added. Let's subtract. So I get 3x is greater than 3. So far, so good. Now I'm about to divide. And I got to remember that if I divide by a negative, I got to flip my sign. Fortunately, I'm dividing by a positive number. 3 divided by 3 cancels out because it becomes 1x is greater than, I don't have to flip it since it wasn't a negative, 3 divided by 3 is 1. So there's my answer as an inequality. If that was all that it asked me to do, I'd be done, but it wanted me to give the answer as an inequality and in interval notation. Because it's not, or equal to, I know I'm going to be using parentheses. And I know because x is greater than 1, it's going to go from 1 to positive infinity. So I have 2 answers. Inequality, interval notation. All right, so solving a linear inequality in one variable. We're just going to simplify each side separately. Maybe I would have needed to combine like terms, and then isolate the variable. All right, let's look at one more, at least one more, and then we'll do some compound. Okay, so 4 minus 5x is greater than 24. All right, once you get used to it, you'll already see there's something that's going to mess with us that we have to take care of, but let's work our way to it. I need to get this x by itself. I'm going to start from the outside in, so I'm going to start further away from it, get rid of this 4. To get rid of a positive 4, I need to subtract it from both sides. So I get negative 5x is greater than 24 minus 4 is 20. Now I need to get rid of this negative 5, and that's where I should have a red flag going off right now. When I see a negative attached to it, I know I'm going to have to flip my inequality sign. So when I divide by negative 5 divided by negative 5 cancels, I'm left with x. I've got to flip my inequality sign. 20 divided by negative 5 is negative 4. So that gives us the answer as an inequality. And when I go to do it as an interval, I know because x is less than, that it's going to go from negative infinity all the way up to negative 4 with parentheses on both of them. And I use parentheses because there is no or equal sign. All right. So one of the most common mistakes with these are, most of us do really good at adding and subtracting to get rid of the constant. Most of us do really good at multiplying or dividing to get rid of the coefficient. Where we make our mistake is we forget to flip our sign whenever we divide or multiply by a negative. So you're going to have to be really careful on that part to not do that. It would stink to do all the hard stuff and then forget the easy thing. All right, let's look at a compound linear inequality, and how do we solve that? So if we have 20 is less than 10x, which is less than 30. All right, this is example 2.2d. It wants us to solve the inequality and graph it on the number line, express the solution as an inequality and in interval notation. Okay, so first thing I need to do is solve the inequality. Problem is I have a 10 attached to my x and I want x by itself. I know it's being multiplied. The opposite of multiplication is division, so I'm going to divide. But what do I divide by 10? Normally I do both sides of an equation or even both sides of an inequality. But here I've got 1, 2, 3 sides technically. So I'm going to do it to everything. If I divide this by 10, I've got to divide this by 10, and I've got to divide this by 10. 20 divided by 10 is 2. I don't have to change my inequality signs because it's a positive. 2 is less than 10 divided by 10 cancels, leaving me with x. Less than 30 divided by 10 is 3. So now I'm gonna graph that on the number line. I know I need a 2 and I need a 3. I know it's gonna be open circles because they're not or equal to. And it's in between. You can pick a test point. You pick 2.5, 2.5. 2.5 is bigger than 2, less than 3, that's true, and right here, I'm shading in the middle. All right, so I know this is my inequality, compound inequality. This is the number line. The last thing it wanted was interval notation, so I know that it's gonna go from parentheses, because it's not or equal to, parentheses 2, all the way up to 3, also in parentheses. So this is what my answer should look like. The inequality, the number line, the interval. All right, so again, the thing to be careful on, they're gonna throw a bunch of minuses or negatives in there to make you have to flip those inequality signs. You're gonna have to be really careful to catch those. So we'll do one more. Do 2.2e. I've got 12 is less than or equal to negative 4x plus 4 is less than or equal to 48. Already I can see, ultimately I'm going to have to flip my signs because there's a negative attached to the x. So I know that's coming, we'll work our way to it. Just like every other time, I'm going to start with this 4 first. It was being added, so I'm going to subtract it. If I subtract it from the middle, I'm also going to subtract it from the outsides. 12 minus 4 is 8, which is less than or equal to negative 4x, which is less than or equal to 44. Now here comes the part where I got to flip. I'm about to divide. I need to get rid of that negative 4. It's being multiplied. The opposite is to divide. Divide this one by negative 4. Divide this one by negative 4. That's, now I've done the operation. That means I need to flip the signs. 8 divided by negative 4 is negative 2. Flip it to greater than or equal to. Those cancel out. Flip it to greater than or equal to. 44 divided by negative 4 is negative 11. So negative 2 is greater than or equal to x, which is greater than or equal to negative 11. That's my inequality. Be my number line. I know I need to have negative 11. And I need to go all the way to negative 2. Because there are equal to's, they're going to be dots. And if I pick negative 5 is right in here somewhere. And it definitely makes this a true statement, so I'm going to shade in between. We've got our inequality. We've got our number line. Last step is to get our interval. I know that it goes from negative 11, including negative 11, so I'm going to use a bracket, negative 11, and it goes all the way to negative 2, including, so I use a bracket again, negative 2. All right, so don't get in such a rush that you forget whether it should be a bracket or whether it should be a parenthesis. That's all pretty easy things, really small concepts, but really, really easy to make mistakes on. So just be careful on those. That's it for 2.2. You've got your practice problems, your homework problems. Definitely do those while they're fresh on your mind, so you keep those things in mind. So you've got open and closed, bounded and unbounded. You've got your addition property of inequality and your multiplication property of inequality that you need to keep up with all those things. All right, so yeah, we're good. All right, so we'll pick up where we left off next time.